Assume that a simple random sample has been selected from a normally distributed population and test the given claim. Identify the null and alternative hypotheses, test statistic, p-value, critical values, and state the final conclusion that addresses the original claim. A safety administration conducted crash tests of child booster seats for cars. Listed below are results from those tests with the measurements given in HIC, Standard Head Injury Condition Units. The safety requirement is that the HIC measurement should be less than 1000 HIC. Use a 0.01 significance level to test the claim that the sample is from a population with a mean less than 1000 HIC. So if we look at a picture of the situation here, it says that safety requirement is that the HIC measurement should be less than 1000 HIC. Now, if we hypothesize that the population mean is 1000, then to show with a sample that the mean is actually less than 1000, our sample statistic would have to land way down here to the left with alpha equal to 0.01. That would dictate a certain critical T level, which we could look up using StatCrunch. We'll click StatCrunch, Stat, Calculators, T. Now, we're going to need to know what the number of degrees of freedom for this problem would be, so we'll look here and see that we have a sample of 1, 2, 3, 4, 5, 6 data values. So the number of degrees of freedom would be 1 less than that, or 5. We want to match this picture that we've drawn, which has the critical region or the rejection region down here to the left of this T critical value. So we're going to leave this as less than, and the area out there in that tail is 0.01. Click Compute, and this gives us a T value of minus 3.365 if we round to 3 decimal places. Now, from this picture, we can see that our hypotheses should be, if we are hypothesizing that the mean is 1000, we would reject that and conclude that the mean is less than 1000 if we land way down here. The alternative hypothesis is what we would conclude if we land in one of the rejection regions, depending on the problem, and this time it's less than. So A would be our selection here. The next question then is to identify the test statistic. Well, so in order to do that, we'll use StatCrunch, and we need to use these data values to calculate that test statistic. So we'll click on this box here, and now that'll copy that data set to a table that we can then paste into StatCrunch. So we'll click StatCrunch, Data, Load Data, from Paste, then paste the values into the box, leave the delimiter as white space. We do not have a first line that has the column names, so we uncheck that, and then hit OK. Now this data has been put into a list that we can use now. If we push Stat, T Statistics, one sample with data, select that column, that's the one we're going to find a T statistic for, hit Next. We want to do a hypothesis test where the mean in the null hypothesis is 1000 and the alternative hypothesis is less than. Then we'll click Calculate. Now this gives us an output box that gives us everything we need to know, and the thing that we're supposed to find right now is this T statistic, the test value, minus 3.957 if we round to 3 decimal places. So we'll type this in here, Check our answer. Now we're supposed to identify the p-value, and this output box also gives us our p-value, which is 0.0054. The critical value, we've already found that, and we put that on our picture. That was minus 3.365. Now we need to draw our conclusion. Let's go back to this thing here. What we found was that our t-test value was minus 3.957. And we put that in here. Now, this value, minus 3.957, is less than minus 3.365. What we would do is, if our t-test value were less than minus 3.365, this critical value, that would lead us to reject the null hypothesis that the mean is equal to 1,000, and then conclude what is in the alternative hypothesis, which is that the mean is less than 1,000. Well, our t-test value was minus 3.957, down here to the left of minus 3.365. We did land in the rejection region, so we should reject the null hypothesis. Another way that we could address that is by looking at the p-value. The p-value is the area outside of the test value, the area under the tail outside the test value, which is going to be less than the area in the tail outside of alpha this time. Since the p-value is less than alpha, we should reject the null hypothesis. So we look here at the conclusion. We should reject the null hypothesis. There is sufficient evidence to support the claim that the sample is from a population with a mean less than 1,000 HIC. Do the results suggest that all of the child booster seats meet the specific requirement? The choices are yes, because the majority of the sample measurements are less than 1,000. B, the results are inconclusive. C, there is not strong evidence that the mean is less than 1,000 HIC and one of the booster seats has a measurement that is greater than 1,000 HIC. D, there is strong evidence that the mean is less than 1,000 HIC, but one of the booster seats has a measurement that is greater than 1,000 HIC. So we'll check D.